Okay, good morning, good afternoon, good evening, wherever you are. Welcome to Big Data Days 2024, day number 2, track 2. My name is John Wee. I am your host for today. Right, today we are very fortunate to have John Mousa, who is from Amazon Web Services, to help us to talk about how do we build an end-to-end data strategy for analytics and generative AI. Hi, John. How's things going in Berlin?
Yeah, things are going really great. We currently have the AWS Summit Berlin going on, so the
Wow.
AWS vibes is everywhere in the city.
Well, we are grateful that you can actually take a little bit of your time off today while you are having that conference to also join us here to enlighten our audience on this specific topic. Right, I'm going to hand over
Sure.
the session to you to take us through this very important topic as well. Over to you, John.
Great. So, welcome everyone. I'm John Mousa. I'm a senior solutions architect. I've been working with regulated enterprises here in Germany, and after some time, I moved to digital native businesses. And throughout the journey with also customers, the topic of data strategy keeps coming up uh, to try to harness the value of data and channel that through business value. It's a very hard thing to do. It's not an easy subject. And now with the rise of generative AI, this has become even more challenging. And what we are going to look at is how are we going to generate value out of our data with a data strategy. And we'll see how generative AI can play an important role here in order to streamline parts of our strategy. What we are going to discuss today is what does it really mean to have this end-to-end data strategy? Then we're going to discuss several ways of how you can build a data strategy with the AWS service offerings. We'll see how generative AI can elevate the experience for you across the board. Maybe initially just a quick business context. Uh, you have probably heard the term generative AI maybe way too much. But the thing is, right now, we see a lot of momentum moving forward. It's not just with businesses doing certain kind of simple productivity workflows, but we also see this now accelerating business use cases. And we're going to discuss some of the example of those business use cases. But going from this point of understanding the importance now of generative AI use cases, we need to make sure that we really understand what's meant with a data strategy. Because usually the first things that comes to mind when we're talking about data strategy is a data platform. And many people would think that if I have a really good data platform, if I have a really good solid technology, then my strategy is going to be centered around what this technology can offer to me. But in fact, it starts way earlier than that. At Amazon and with AWS, we usually look at everything from the point of working backwards. We love to look at the use cases and what kind of business value do you want to enable, and then from there define what should be the outcome and what should be the technologies that you focus on and build to enable those experiences. That's why when we talk about data strategy, we actually talk about three important pillars. First, the mindset. This boils down mostly to the kind of experiences and use cases that you want to enable. But it also is a change to how everyone in the organization thinks about how they consume data, how they build products with data. Speaking about everyone, we here are talking about people and process. This boils down to the people that you have in your organization, the stakeholders that are going to use the data, and the process is how they're interacting with each other in order to achieve the outcomes that they desire. And then we talk about technology. After we identify all of those items and elements of our data strategy, then we start talking about how can we use technology in a purpose-built way to reflect on the goals that we want to achieve. Let's have a quick look at what we mean really by mindset. With generative AI, we have seen some predominant categories of use cases. those start with productivity use cases, and that's something that would increase the productivity of people. But if we want to put it into action to enable some business outcomes, we see things like enabling your customers to do things faster, looking across the board of a lot of data, and then understanding what this data means to enrich more what you want to learn about your customers and about your businesses. And then you can maybe offer something like a search to enable people to have a first look about the kind of assets that you have. But from there, you can drive recommendations and additional services to your customers in order to achieve different outcomes or accelerate business value. And when we look at generative AI, we usually look at the model and point at the model or the dashboard and see that this is the outcomes that we want to achieve. But this is just the tip of the iceberg, because to achieve this, we need to look at the data holistically. We need to look at what kind of things that we're building with our strategy in order to lead to those AI use cases. For example, let's look at a personal virtual assistant. This assistant would help you, for example, book the trips that you want to do, your dream trip. In order for it to be effectively doing that and provide relevant information, not just any kind of generic information or undesired information, to provide relevant stuff, it has to work backwards from two types of data. What you are offering as an organization, for example, if you are offering some certain flight offers or hotel promotions or similar travelers' preferences, and the actual traveler data. What is their history, preference, profile? What kind of things do they like to do? From there, if you ask an assistant to plan a trip for you and engage in a conversation, it's going to be a meaningful conversation. Otherwise, it's really going to be an irrelevant conversation, and customers are going to tune out of those generic conversation pretty early. Another example is having a connect with your brand. This is basically something that would allow your customers to explore things through, for example, a conversational interface rather than try to click through your website to discover what they really want. But here again, this needs to have information built on top of your own offerings, your inventory of things. And that inventory can be changing. It can be also changing on a very high pace. So you need to make sure that you're always providing relevant information through your generative AI use cases. I think we talked a lot about the use cases, but now we can move forward to technology. How can we then enable such experiences? With And I probably alluded to that. We don't think that there is one size that fits all. It's not just one model that's going to rule everything. What we really want to think about is what is the experience that we want to enable, work backwards from that experience, and look at the patterns that should enable that experience. For example, we can start with a relational database if we have an operational system that's handling manageable amount of transactional data. But as we are moving to a bigger inventory that's faster changing, we might then need to have a different kind of database, like a NoSQL database, that's really optimized for those key value lookups. Now our data has changed, and then our context has changed for our generative AI use cases. That's why our technology always needs to be flexible and adapts for these kind of changes. And today, we are going to propose some high-level components about what your use case can be implemented with as an architecture for a generative AI use case. We're going to look at two different things. First thing is what's happening behind the scenes. How are you collecting data from various sources? Whether you're collecting them in batch or whether you're moving towards near real time and you're streaming data, then we need to analyze this data. Let me try to highlight that even better. So then we analyze this data through maybe real-time stream analysis, or if we have our data lake that includes our data from various sources. But then we're going to have a consumption model for this data. The most important thing that we're going to focus on is your large language models that's trying to generate insights for your data. But in order for it to be effective, it's going to interact with a vector data store. A vector data store, we're going to discuss that in details, is going to look at the kind of information that you have, but presented in a way so that a large language model would really understand it and interact with it in an efficient way. You would also have additional conversational histories or additional context you're building with your users and operational databases. And we're going to also discuss some of your choices there, all leading to this point, which is your application that's providing generative AI capabilities for your users. All right, let's start with the data behind the scene. As we mentioned, we looked at various types of data, and that's why we need our data lakes and our data warehouse to be flexible enough to host all these kind of data. But then from there, we need to channel the data through the right mechanism or the right service in order to consume this data from our data lake. Let's look a little bit about how we're going to look about our data sources and integration of those data sources. Usually, we look at the different data sources that we have that we're collecting data from as those kind of discrete types. But in order for us to provide a full picture for data, we need to integrate this data together. I'm going to give you an example. Order data or shipment data is something that's very helpful for tracking a single order. But in order to build a customer journey dashboard, we need to integrate what was the browsing history and what was the lookup for customer for your services and integrate that with the operational details from the backend about the orders and how they are being shipped in order to understand what happens from a customer click on your item, buying it, until it gets delivered, and what was the feedback of the customer for the whole process. This would enable you to recommend better services and better products for your customer and drive value. These are the kind of things that are going to integrate your data across multiple different sources. So for that, we have to do multiple steps throughout the way in order to bring the data from their initial data sources to the integrated layer, to the integrated full picture of your business or entities that's going to drive those experiences for your customers. And we have a lot of purpose-built databases and data warehouse products that you can use at AWS. Those services are good at what they do, and they are purpose-built for the jobs that they are meant to deliver. Let's start with one example, which is Amazon Aurora. This is something that all customers can get started with easily because it's a MySQL and Postgres compatible relational database that's designed for performance and scalability, all at one of the tenths of the cost of enterprise-grade commercial databases. Aurora has a lot of innovations inside. It spans from serverless consumption models where you don't have to provision any hardware to some of the innovations in scaling and availability across multiple regions in AWS. Then we can dive into ingesting near real-time data or real-time data. And we have a range of streaming services that can go from totally managed services, like with Amazon Kinesis data stream, or having a managed offering on top of open source offerings like Apache Kafka with Amazon managed streaming for Apache Kafka. And to do analysis over the data, you can use Amazon Managed Service for Apache Flink to do real-time analytics on top of your data. But as you have seen, our service that would enable you to integrate data across multiple data sources we always consider Glue as our service that's going to anchor the data integration. It features serverless execution, so you don't really need to care about any kind of clusters or provisioning or anything like that. All what you need to do is describe your jobs, and it's built on top of Spark, and you can use Python or Ray even to express your data jobs. Glue has a visual editor that would allow you to just drag and drop the elements of integrations that you need about your services, and then you can use that to build your integration pipelines. But speaking about integration, AWS is actually investing in a zero ETL future where you don't really need to specify the pipelines. With zero ETL, the data moves from the source to the destination in a native way, right? You don't need to express a lot of things. And we take care of the undifferentiated heavy lifting of making this reliable and scalable based on your data volumes. For example, Aurora, the database service that we mentioned, can provide zero ETL integration into Amazon Redshift, our cloud data warehouse. With Amazon Redshift, you can then analyze data that is structured coming from a database like Aurora, or you can also analyze semi-structured data and integrate the data together and query the data on a petabyte scale in near real-time analytics. You can even look at other services, like, for example, Amazon Athena, that provides a way for ad hoc and interactive queries that's built on Trino to federate into different data sources without even the need to move the data from those data sources. Athena can then interface with Redshift, or it can provide an interface for your Amazon QuickSight to visualize the data. And Amazon QuickSight is our serverless business intelligence tool. These kind of ways of Redshift and Athena to look at your source data in a zero ETL fashion integrates also across streaming data. So you can also do zero ETL with ingesting streaming data from MSK, our managed offering for Kafka. All right. We talked a lot about can you integrate multiple data sources to build a holistic picture that would be useful for our generative AI applications. But how can I use generative AI itself to help improve my productivity with building those integration pipelines? When we talk about generative AI, we talk about multiple things. At the bottom of the stack is, of course, the infrastructure. This is the most comprehensive tools that would allow you to build quick and cost-effective large language models and foundation models to run inference at scale. In the middle layer is the easiest way for customers to build and scale generative AI applications with large language models and foundation models. And here we're going to dive deeper a little bit into Amazon Bedrock, but for now, we are going to focus on applications that just use those foundation models and large language models as a service. This is empowering everyone to use generative AI. For example, with Amazon Q for business, you can enable your business users to start doing analytics on top of the data in an easy way. And with Amazon Q for developers, you can allow developers to start boosting their productivity to build integration pipelines or code in an easy way inside their favorite IDE, or also the multiple web experiences that we provide for developers to build analytical applications. For example, if you try the visual interface for Glue to build your integration pipelines, it's really great. But once you start building some custom logic for integration, you can switch from the visual mode to writing your own code. Once you do that, you will get the integration of Amazon Q inside the editor, and then you can just type a comment and let the Amazon queue continue and build for you the actual functions that you need in order to transform data. We talked about Amazon Redshift, and now we're going to dive deeper into Amazon Redshift, which enables you to securely and easily, in a reliable way, analyze your data across your data lake and also structured data. With Redshift ML, you can just use your SQL dialect to start tapping into any large language models that you have deployed in the bottom stack layer of your generative AI stack. This would be something that you will define as an SQL function, and then you can start using this function as a function to transform your scalar values. But interestingly, you can provide what we call a super data type. A super data type is just a schemaless data types that would harness or have a lot of the semi-structured data inside it. So this can be any JSONs that you provide. And now you can reason on top of your data from your uh, cloud data warehouse with an SQL function without leaving your realm of a cloud data warehouse. We also provide Redshift Query Editor, which is an easy way for developers to tap into the power of Redshift from the browser experience. It doesn't only provide you a way to execute queries, but it also provides a simple way to start visualizing the values or the data that's coming out of those queries. And as you might expect, with generative AI, you can start asking questions about your data, and then it would generate the SQL statements that are needed to be executed. And you can then choose those SQL statements, or you can update them and then start executing those statements directly from the query editor, all powered by Amazon Q. For example, it's going to, here, we're going to ask it to count the number of schools in a certain county. And while a natural output would be something like this, you're asking where a district equal the district that you specified in your prompt. Redshift actually knows your database and tables and schema and joins the right tables in order to give you a query that executes in the correct manner. For example, also, if you ask it about a product description and then ask it for where does it or the product descriptions sorry, the transactions that happened in a certain country, you might think that a query would be like this, but because Redshift knows your data, it knows that you're storing your country in certain codes. So it actually personalizes the output for your data. Finally, when you have a complicated schema and you're joining across multiple tables, you can just ask it to start having a prompt that would need to join multiple tables in order to get a result. But with Amazon Q, it provided aliases as a best practice so that it does not provide some kind of a query that would be ambiguous in some of those aliases. Once you have your right SQL, now you want to use a business intelligence tool to start looking at your data from different sources, whether that's Redshift, Athena, or even some other external data sources, and do some business intelligence on top of that. Build dashboards and build narratives around your data. And Amazon QuickSight is something that scales serverlessly. You don't manage anything about it, and it has a very effective price model per user. What you can do with QuickSight currently is just use automated forecasting, and you can use Amazon QuickSight Q to ask questions. More interestingly, you can ask why questions. So you have your visuals, and you can say, oh, why did the sales drop at a certain point in time? And then it would try to correlate from other data sources where is the drop happening, and would try to give you some reasoning behind this. With the addition of Amazon Q, Now you can have dashboard authoring experience that's powered by generative AI. So you can type a prompt and say, I want a visual that represents, for example, sales over time. And you can also engage in a conversation. So you can actually ask to change this visual type from a bar chart to a pie chart. And Amazon Q is going to understand that and provide you the right visual for your data. Once you're satisfied with the visual, you can build a complete dashboard. But here's the interesting bit. You can still use Q&A uh, uh, chat capability to actually start asking questions about your data from the complete dashboard. And in a more powerful way, you can build a story around your data. So you can ask Q to summarize your dashboard and build an executive report that allows executives to look at the important parts of your data. And you can edit every part to make it, for example, for the introduction or the context, you can make it shorter, longer, more descriptive, less descriptive. All of that is something that you engage in a conversation with uh, Amazon Q to customize that dashboard and to customize the stories that you're building around your data. All right, we looked at what's happening behind the scenes. Let's look at the other end. And I mentioned the vector data store and I mentioned your LLM. So let's look at the vector data store. But first, let's have a look at what is vectors. Vectors is a way to encode multiple attributes about your data in a machine readable way where large language models can reason about your data. It's just like combine multiple attributes of your data in just some things that we're going to call vector. And a vector can run in multiple dimensions. In fact, it can run in millions of dimensions. So we are building vector search capabilities across a lot of our databases, like DynamoDB and Aurora that we just mentioned. But more interestingly, we're building that with OpenSearch. OpenSearch, Amazon OpenSearch is a service that provides for you a managed way to do full text search about your service. And you see where this is going. It's very good about reasoning about text, but it also provides an interesting opportunity to reason about vectors that it understood about your text. And with our vector engine, with Amazon OpenSearch, especially in a serverless deployable way, we can provide you a way to reason about your data from your data lake directly in Amazon OpenSearch. And then you can ask Bedrock to start reasoning about the data from those vector stores because we provide an integration. I've talked a lot about Bedrock, but I want to spend 2 minutes on Bedrock itself. Bedrock is a way to abstract multiple models, your choice of a foundation model, whether these are open source or provided by Amazon itself, and it provides an interface that allows you to reason on that. We've also recently announced Amazon Bedrock Studio that allows you to also put guardrails on top of how you're reasoning with those different models. You can switch the model underneath, but you don't have to switch how people are interacting with your large language model because it simplifies this across multiple models. With vector databases becomes an additional point for Bedrock to reason about with the large language model of your choice. So you start with your data as it's stored in your data lake, and then you feed that to whatever models that you're going to select. Once you do that, the model starts now interacting through Bedrock with your vector data store, and then it can power your use cases and generate content, like, for example, social media outreaches or display certain information about your users that are reasoned across multiple users. Of course, customizing your foundation model is a powerful thing, and Bedrock can simplifies that for you and also abstracts that. But make sure you first exhaust your options with prompt engineering with existing models, and then maybe think about training your own model, because you would need to have data that's labeled in high quality in order to be able to reach good results with training your own foundation model. One important thing that we need to think about throughout this whole journey, and I left it on purpose on the first architecture, but it is here at the bottom side of the architecture. It talks about data governance, and this is in parallel to data integration. This is something that's happening across the board of this whole process, end to end. At AWS, we provide you a lot of services to manage governance in the integration layer, like how you use lake formation to govern access to your data in a centralized way, which works with AWS Glue, Athena, and Amazon Redshift. But also provide you for ways to govern your machine learning models with Amazon SageMaker. Amazon Data Zone then sits on top and provides you this cataloging and discoverability, and also additional governance tools that you use on top of your data to provide secure access for your data for different stakeholders. And on the other side, for the end use cases, we provide you ways that to use your identity that's stored in some kind of an external identity, or with using Amazon Cognito, but you can federate the identity across any identity provider in order to be able to access your applications. And throughout this whole process, we're always auditing everything for you. So you can always tap in something like the logs that we provide for all the services that you have seen. Every one of those services has a perimeter, which is your enterprise data perimeter. And throughout this perimeter, we're collecting events and logs for you to analyze. No one accesses your data without your permission. And you're always aware about any of the internal AWS service that needs specific access to certain parts of your data in order for it to perform its job. You always allow that, and you can always watch that with CloudTrail and also with CloudWatch. All right, we've talked a lot about the architecture, and we also have seen different components of integrating your data and analyzing your data behind the scene. What kind of things that generative AI can help to boost your productivity. But most importantly, we've seen how this would lead you to enable the applications that are hopefully working backwards from the business value in order to determine what kind of stores that you need for your vector data stores and what kind of models that you need for your foundational models in order to provide a cost-effective way to give the maximum outcome for your business value. AWS provides for you the tools that you can do that in a comprehensive and an integrated way. And it also provides you an end-to-end governance capabilities that allows you to look not just at the machine learning part, but also at the data part as well. The models that we always think about is that your data is something that allows you to query and analyze uh, um, uh, multiple aspects that you're collecting from different data sources, but it's the action parts and models that are going to provide actionable outcomes to your stakeholders. But here is the thing, the actionable part is something that you can swap out as per the applicability for a certain use case. So make sure that you give a lot of care for your data part, and then you can swap out any actionable parts that provides value based on the applicability and the cost effectiveness. This is the flexibility that AWS provides for you. All right. If you want to dive deeper in any of those topics and you have a connection to your AWS account manager, you can just reach out for them and ask for uh, uh, engagements around data strategy. You can always reach out to me. Thank you for sticking around, but because you know that we are at AWS, we're always data driven. I would like to ask you to scan the survey, 4-click survey, and at the end of the survey, you're going to have a link for those slides. So feel free to scan this code and provide me your feedback. I read every comment, so make sure to let me know about other things that you want to hear about as well, and let me know about other topics that you want to discuss. With that, I give it to you, John.
Fantastic. I think you have just given a lot of technical information. And I think the amazing part, John, I think you've put it together so well. I was really impressed by all the various components that you have, showcased to us from AWS platform, right? It seems to be very comprehensive. I'm first time looking at it. I'm really impressed in the fact that how the tools can be internet connected and whatnot. Right. We do have a couple of questions in the Q&A. Allow me to project them so that we can, perhaps you can share some of your thoughts. First one, that is actually from one of our attendees here. How does AWS address data privacy concerns when we implement a end-to-end data strategy? Perhaps you can share a little bit more, John, how could that be perhaps protected to a certain extent?
Yeah. So the first thing that we all need to talk about is first something that we call the shared responsibility model. The shared responsibility model says what are the things that you need to take care of and what are the things that AWS takes care of. Well, we take care of the security of the infrastructure and take care of the security of some of the things that we're doing with our services. And this is different from service to service. Because, for example, for serverless services, our shared responsibility part increases in nature. You always have all the control over your data. You're always a person who's setting any kind of permissions for anyone to access your data. So you have this power at your hand, and this is your part of your shared responsibility model to make sure that also your data is safe. We have a lot of things and a lot of suggestions, and Amazon Q is currently integrated with the AWS console, so you can also ask it to whether my bucket is secure or whether I need to add some additional policy controls. But with the tools, different tools that we give you, you can set this security on top of multiple layers. First, the storage layer. Second, you can put it on a logical layer with tables, with, for example, lake formation. And then finally, you can put it for business users where they can share data products and more abstract form of data across each other. We also describe exactly what we do or how we interact with your data in our terms and services. Please check them out.
Right.
But you're always in control of your data, and your data does not leave the region that you've put your data on without your consent, without you asking you directly if, for example, you need to do that, and you are always in control. You have to provide this kind of permission in order to do that, maybe for a disaster recovery reasons or something like that. But if you have any additional things in mind, please elaborate more in the chat.
Right. So I think what you are saying is with this model, I think it is us as the owner of that data having a open dialogue with AWS team and say, look, I have this concern. How could we go about fine tuning this so-called privacy, or how do we even take care of that, like you mentioned, at the various functional level, right? Whether it's logical.
Yeah, you're always the owner. Yeah, you're always the owner of the data. It's right. So you always have the control, and you always have the tools to make whatever parts of your data only private to your use, or if they are open for example, because you want to have an open website where people interact with. So this is something that you're always in control of.
Interesting. Right. Let's look at another question. This is from our audience, Michael. Michael would like to appreciate or understand how does AWS supports the scalability and flexibility requirement in terms of a specific data strategy. So how could we tackle that from that perspective?
Yes. This is a very interesting
Hmm.
question. Uh, but in order for us to unpack this question, um, interestingly, we unpacked some parts of this question in the previous year's
Yes.
session. So if you also go to the YouTube channel, you'll find two sessions for me for last year and the year
Yep.
before, where we were talking about a model that tackles this. It's an evolutionary model, but just in a nutshell, to support your scalability needs, we're investing a lot in zero ETL and serverless capabilities that would allow you to scale as you need and only pay for the stuff that you're using. So you don't have to provision something huge or have one box to do everything for you and pay a lot for that, but rather only pay for what you're
Hmm.
using. Another aspect is that we're always separating data from compute. So in many of our services, you're going to see us using S3 as your storage layer, which is a very cost-effective storage layer. But then your compute is something that's separate from that. And you can scale them differently. You can have petabytes of data, but only scale the amount of compute that you need for the data that you're processing out of those petabytes of data.
So that granular
Now,
control is available to us as what we call as a customer to AWS, right? To really fine tune
right,
what will be a right fit for our specific organization needs. I believe. Yeah, I think that's fantastic,
yes,
John. In that sense.
we have we have a serverless offering for a lot of this analytical services that we have, and also for the streaming services
Mm.
that we have. Now, the other question is the flexibility. And the flexibility is something that's very important for us. We have discussed in previous sessions how can you have a flexible data architecture that separates your integrated data layer from a consumption layer. Because since you have multiple ways that you can consume the
Yes.
data, you can the right service for the right job and always be flexible. You're never locked in to any consumption technology as long as you have an open integrated layer, and we actually support building that on AWS. For example, you can use S3, which virtually integrates with a lot of analytical
Yep.
services out there, and use open formats like Iceberg if you have transactional data, or you can use just Parquet, and the data would be available for those analytical services, not just now, but also in the future as well, because you've chosen an open
I
format.
think that's a very, very good strategy to start with because you don't want to get locked into one specific format or whatnot. I think that's something that we should always keep that in mind when
Mhm.
we so-called engage AWS in that sense. Let me move on to another question. This is an interesting one that I believe I'll project it up.
Mhm.
It's from our audience, Ruby. Ruby is asking, what are the important factors that tend to be overlooked when we build an end-to-end strategy for analytics or generative AI? Yeah,
Yes.
this is actually a
All
very
right.
good one, John.
This is a very good
Yes.
question, and I alluded to that in the beginning of the presentation. The very important factors that people tend to forget about is that the technology is just a secondary
Correct.
part of your data strategy. The most important part is that you sit down together with the business or you inspect
Mhm.
correctly what is the business outcomes that you want to achieve. Where are you going to grow? In which areas? And what are the use cases that are going to support these growths? Now, we have a way at AWS that's called working
Yes.
backwards. And if you did not engage in any of those workshops, I heavily suggest that you just get in contact with your AWS contact if you have an AWS account and ask them to about resources about the working
Yep.
backwards methodology. Once you define your use case, now you can look at where do you need to collect data from. So this would be your data acquisition part. And then from there, you can start classifying your data and start putting some kind of data classification to understand how you're going to store your data and what kind of security controls you're going to put on your data. But the things that's mostly just going back to the answer to the question in a
Mm.
nutshell, the things that we tend to somewhat forget about is that technology is not mostly the blocker. It's really what would happen if you have all the technology in the
Yep.
world? What are you going to do with that? If you think from there and work backwards, you're going to have the right technology to support your data strategy.
Thanks for mentioning that, John. Actually, I was very privileged in my previous organization to work with some of your colleagues from AWS to learn the working backwards methodology. By the way, for the audience, I believe there are books out there as well, so you might want to check some of the title called Working Backwards from AWS. It's actually part of a design thinking kind of a AWS way of getting things done. If you do invest and go through that process, I think you will learn a lot of how the thought process of finding out the right way of doing it. Again, John, thank you so much for your time. I think it was very enlightening as usual. I think you've shared with us a lot of interesting technologies, a lot of interesting parts that we should look at when we engage or work with AWS team. Again, really appreciate your thought on this. Thank you again for taking time out. I know you have an event to attend to in Berlin. You're on back-to-back as well. We're always really grateful for you to join us. All right. Thank you, John.
Thank you, everyone, and happy to be here.
Next up on the hour, we do have track 1 from AD and track 2 from Period as well. Do join us on the other side as we conclude the session now. Thank you, everybody, for joining us today. Thank you, John, again. We'll see you soon. Cheers.
Bye.